All right, we're going to continue our work on lesson 5.2 today, which is on writing equations in standard and point slope form. We worked yesterday on just those two forms and making sure we could write things correctly in those forms. Today, we're going to add a concept of parallel and perpendicular lines to go with our work in the standard and point slope form, and how their slopes really affect the answers and how we write them from there. So, just jumping into it here, parallel and perpendicular lines. Okay. When we look at parallel lines, if you were to graph parallel lines in a coordinate plane, all right, these lines are lines that will never intersect. They will always remain an equal distance apart. And what happens is parallel lines are going to have the same slope. So if I told you AB and CD were parallel, they need to have the same slope. So if you look at here, we got B. If we go from B to A, it's a rise of 2 and a run of 1, 2, 3, 4, 5, 6. So that's a rise of 2 and a run of 6. That's up 2 to the left 6. So it's 2 over negative 6, which is negative 1/3. Okay. If you come down here to CD, it's a rise of 2 and a run of 6. So that's a slope of negative 1/3. These two lines are parallel. Okay. They have the same slope. So we write parallel using these two parallel lines right here. Line AB is parallel to line CD. So the key here is parallel lines have the same slope. Okay. Lines that are perpendicular. Okay. Now, perpendicular lines, let me get them up here, are, are lines that intersect, yes, but their intersection is special in that their intersection forms a right angle. Okay. So it's got to be a right angle right here. So when lines are perpendicular to one another, they are going to intersect to form right angles. And what we know about their slopes are they have to be opposite reciprocals. Okay. The opposite reciprocals means one's positive, one's negative. Okay. So the opposites have to be one positive, one negative. Reciprocal means flip their fraction. All right. Now, another way of looking at opposite reciprocals would be if you multiply their slopes together, you get an answer of -1. So let's just look here. EF has a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3. So that's up 6, which is positive, to the left 3, which is negative. So rise over run is 6 over -3. That's -2. So this slope is -2. Okay. So I could have went up 2 over 1, up 2 over 1, up 2 over 1. Okay. Now GF has a slope, which is a rise of 3 and a run of 6. So that's up 3 over 6. That's 3 over 6, which is 1/2. So EF has a slope of -2. GH has a slope of 1/2. -2 and 1/2 are opposite reciprocals. Okay. Now we're going to look more closely at that as we move forward. But that's the two main ideas, guys. You got to write that down and know it. Perpendicular lines, same slope. Or excuse me, parallel lines, same slope. Perpendicular lines have slopes that are opposite reciprocals and they form right angles. All right. Oh, let me go back here a second. This is the symbol for perpendicular, upside down T looking thing. So EF is perpendicular to GH. All right. So you'll see that. We have to know what it means. Okay, so it's saying write a parallel line through a given point. So let's look at the instructions here. It says write an equation in slope intercept form. You're going to have to read this carefully because they're going to want different forms. So slope intercept is y equals mx plus b for a line that passes through the point -4, 2 and is parallel to the graph of the line y equals 3x minus 5. Okay, so if we're going to be parallel to this line is written as y equals 3x minus 5. It's written in slope intercept form. So I know the slope of this line is 3. So our line, if it's going to be parallel to this one, also has to have a slope of 3. So we're going to have to write an equation in slope intercept form for a line that has a slope of 3, same as this one, and goes through this point. Okay. Now that we have this point slope concept in our back pocket, we want to use this. This is actually the easiest way, I think, to go from information to slope intercept form is to start with point slope. All right. So we know we pass through the point, or excuse me, our slope is 3, and we're going through the point -4, 2. So if I load that in here, okay, remember that's x sub 1 right here. That's y sub 1, 2, slope is 3. Okay, put it in here. Now, if I just solve this for y, it's in slope-intercept form. I don't have to go find b separately. So let's go ahead and rewrite this. Instead of negative minus a negative, it's really plus 4. Distribute our 3. Okay. And now if I just add 2 to both sides, it's now in slope-intercept form. B is 14. I don't have to go find it independently now. I have this little formula, this point slope form, that's really easy to solve for y and put in slope-intercept. So there's our answer. Y equals 3x plus 14. This line is parallel to the given line. They have the same slopes. They go through different y-intercepts, and this line will go through the point negative 4, 2. That's what we've done there. Okay. All right. Same kind of deal. Let's be parallel to this line and go through this point. Okay. So, whoopsie. Parallel to this line means slope is 3/4. Going through this point means we're going to use the point 8, 2. Start with point slope, guys. There's your x sub 1. There's your y sub 1. There's your m. Put it in, solve for y. If you hit pause and do that, I'm going to show you the answer. All right, the answer is 3/4 x minus 4. That's what you should get if you do what we did on the last slide and follow through the calculations. Okay. All right, let's talk about a perpendicular line now. So we're going to be perpendicular to a given equation and pass through a different point. All right. So first of all, they tell us the equation we're perpendicular to is 3x plus 2y equals 12. This is in standard form. Ax plus by equals c. We don't know the slope yet. If it's in standard form, that doesn't give us slope. So we're going to change this to slope-intercept first. All right. So to change it to slope-intercept, solve this for y. So subtract 3x, divide everything by 2, and I get y equals negative 3/2 x plus 6. Right. We've done this quite a bit. All right. Now all this work was to figure out what our slope is. So the slope of this line and our new line is going to be negative 3/2. So I'm going to take negative 3/2 as my slope. Now we're going to be perpendicular to this line. So perpendicular means I don't have the same slope. That would be parallel. I have the opposite reciprocal. So now I want to use the slope of 2/3. Flip the fraction, take its opposite, positive 2/3. So now I'm going to take a slope of 2/3, a point of 1, negative 2, and I'm going to write the equation, and they want it in slope-intercept form. So again, my idea, let's start with point slope. Plug in 2/3 for m, 1 for x sub 1, negative 2 for y sub 1, and then solve this for y. Okay, so minus negative 2 is plus. Okay, distribute 2/3 through the parentheses. I'm going to subtract 2. Now, it's negative 2/3 minus 2. Okay, if you want to get creative here and do it without a calculator, negative 2 is the same thing as negative 6/3. Okay, if you divide negative 6 by 3, it's negative 2. This gives me common denominators, and I wind up with y equals 2/3 x minus 8/3. Okay, negative 2/3 and negative 6/3 is negative 8/3. Okay, so that's a simplified answer there for perpendicular through a given point. All right, some questions we get are just going to say, hey, you know what? Let me know if AB is parallel, perpendicular, or neither to EF. Okay, we don't have to write equations for these. All they want to know is, are these two lines, based on the points given here, are they parallel, perpendicular, or neither? So what we need to do is just find slope for them. Slope will tell us. So find the slope of AB. Difference in the y's over difference in x's. Slope of AB, it's a negative over a negative, guys. That's positive 3/4. Okay, what's the slope of EF? Well, difference in y's over difference of x's. Done a lot of this. I get 8/6, which is 4/3. Now, these two are reciprocals of each other. One's 3/4, one's 4/3. However, they are not opposite reciprocals. Okay, therefore, these two lines are neither parallel nor are they perpendicular. Okay, they're just two lines. Now, this is kind of a fancy one, but I thought it'd be good to see this. So it says y equals ax minus 5 and y equals bx plus 3. All right. So when A is 4 and B is 4, what do we know about these two graphs? Well, if this was y equals 4x minus 5 and y equals 4x plus 3, what we would know is they have the same slope because the A in this equation and the B in this one represents the slope, right? So they would have the same slope, so these lines would now be parallel. All right, what if A was -3 and B was 5? Well, then the slope would be -3 and 5. Those are neither the same nor are they opposite reciprocals, so that'd be neither. And if A was -2 and B was 1/2, okay, then 2 and -1/2 are opposite reciprocals, so those two lines would then become perpendicular. Okay, just a fancy way of asking the same style of questions. Okay, that takes us through the information we're going to use today. We're going to continue to work with all of our different forms of writing the equation for a line: slope intercept, point slope, standard. Okay, but we're going to be given information differently and asked to write the equations as they are given to us. Okay, so take a look back through this. Make sure you write notes down to help yourself. Okay, and I will let you get started.